A solid sphere with a radius of 75 millimeters rolls down an inclined plane that is 5 meters long. What is the angular velocity of the sphere at the bottom of the plane if it requires 10 seconds to reach the bottom? What is the angle of the plane?
To find the angular velocity of the sphere at the bottom, we should find the linear velocity of the sphere at the bottom first. Since these are the givens, we can easily find the final velocity at the bottom while using the kinematic equations. Let's use delta x equals v initial t plus 1/2 at squared. We know v initial is 0. We know delta x is 5 meters, and we can find the acceleration here. Then acceleration is 0.1 meters per second squared. By using this acceleration and another kinematic equation, v final equals v initial plus at. We can find v final. V initial is 0, acceleration is 0.1, and t is 10 meters seconds, and v final is 1.00 meters per second. And we know that v linear velocity is equal to r times radius times angular velocity. Then 1 meters per second is equal to 0.075 meters times the angular velocity. Then angular velocity is 13.3 radians per second. The second question asks what the angle of the plane is. To find the angle here, we should find the height of the plane. To do so, we can use conservation of energy. Potential energy at the top is equal to linear kinetic energy plus the rotational kinetic energy at the bottom. Mgh equals 1/2 mv squared plus 1/2 I omega squared. We know the question says it's a solid sphere. Then we know moment of inertia is 2/5 mr squared. Then we can substitute it here. Then we can cancel out m's. Since velocity is equal to r omega, we can say r squared omega squared is equal to v squared. Then the equation becomes gh equals 1/2 v squared plus 1/5 v squared, which is equal to 7/10 v squared. We already found the v here, which is 1. We know g 9.81, h 7/10 times 1, h is 0.0714 meters. Now we found the height of the inclined plane, and we know the length of the road. We can simply use sine inverse here, 0.074 divided by 5, which gives you 0.818 degrees. This is the angle.